Welcome to single phase part 3. So in this part, we will look into standard temperature and pressure, or known as STP. This STP is used as a conversion factor in single phase chapter. For example, if you do not want to use R, you can replace R with STP in order to find the unknowns in your question. Okay, so how do we use STP? Okay, so this ideal gas equation at STP will look like this. Previously we have PV equals to an nRT, but for ideal gas equation at standard temperature and pressure, STP, it will look like this: PS standard, P standard, V specific molar volume standard equals to RTS standard. Okay, so this is the equation of ideal gas in terms of STP. STP means the condition of the gas is at T equals to 0 degrees Celsius or at 273 Kelvin. P is at 1 atm. But in your textbook, in your table, you have there is complete STP information for you. Okay. So how do we use this STP as a conversion factor, replacing R? So we know we have equation PV equals to nRT, and we divide the equation of ideal gas at a normal condition by the ideal gas STP equation. So PV equals to nRT divided by this equation, the ideal gas equation STP. We rearrange the equation until we get like this. Okay, so we'll see. Previously, from the first we still have R, but because we will cancel off R, so after we rearrange, we no longer have R. That's why we say that for this STP, if we use STP, we do not need R, the gas constant information. So we can use STP as a conversion factor. So from here you can find whether you want P or V or N or T according to your question. To find P, V, T, you can use the equation, we can use this equation, the one that we obtain by dividing the ideal gas equation with the ideal gas equation at STP. So using this, you do not need to use R. Okay, so you may find in your textbook later standard cubic meters, or short form given as SCM. The standard cubic meters SCM means your STP in terms of meter, your volume in terms of meter cube. If you have SCF, or known as standard cubic feet, SCF is when your STP volume is in feet cube. Okay, so this is the complete table for STP. Okay, this table is actually in your textbook, table 5.2-1. Okay, so we have in the table it listed 3 types of STP based on different unit. Okay, so in SI, so your TS will be at 273 K. This means equivalent to 0 at 0 degree C. P, your standard condition at 0 degree C, or in Kelvin, is 273 K. Your standard condition for pressure is 1 atm. Your volume, okay, a number of mole for this standard condition, and your specific molar volume, you get as 22.4 meter cube per kmol STP. So this is the SCM. This is what I meant by SCM. Yeah? Okay, so to get this is just divide your volume and with your number of mole of STP of this condition at this condition, then you'll get 22.4. But you see, this is 1 mole, this is kmol. So when you divide it, so you'll get, if you change it into kmol, then you'll get 22.4. So you have also in CGS unit, where, okay, standard condition is similar to SI. It's just that for volume, it is in liter. And still number of mole is 1 mole because it's standard condition. So when you find specific molar volume for CGS, is this volume. Okay, for American engineering, the standard condition for temperature is at 0 degrees C, which is equivalent to 492 degree Rankine. The pressure is at 1 atm, similar, same unit as the other unit. But for volume is in feet cube, and mole is in pound mole. So when you want to find the specific molar volume that relate to this is this divided by this, then you'll get this. This is the one that refer to standard cubic feet. Now I'll show you one example how we use STP as a unit conversion factor. Okay, we have example of the question sounds like this. We have a system where the pressure gauge shows the pressure gauge on 20 cubic meter nitrogen at 25 degrees C reads 10 bar. Estimate mass of nitrogen using conversion from STP. So the question wants us to find the mass of nitrogen using STP, not using the without using the regular R gas constant. Okay, right, we are given information. So what do we have? We have volume, we have temperature of the process of the system, and we also have the pressure of the system. So the question wants us to find mass. We from PV equals to nRT, we do not have directly mass. We cannot determine directly mass, but we can find, we can find mass by knowing what is N from PV equals to nRT, right? Okay, so to find mass of this nitrogen, we need to find N, because after we get N, then we get number of mole, we're going to times with molecular weight of nitrogen, then we'll get mass. Okay, so we have volume. We list down what do we have in from the question. So we have volume, we have temperature, we have pressure, and because it's nitrogen, and we need the molecular weight of nitrogen. So you can get the molecular weight here from your textbook at the table behind your textbook. Okay, since so in this question, since I would like to use this SCM, I want to find in terms of mole, so I use standard cubic meter. So this is the SI unit which I got from the previous table of the STP. So anything information given in unit using a unit different from the STP table, so we need to convert it. So for example, we do not have to convert volume because we are using SCM, so volume in SCM is meter cube. Okay, but for temperature, standard temperature is in terms of Kelvin. So in order to find the temperature in Kelvin, so we have to add 25 plus 273. So we'll get the absolute temperature for the system is 298 K in Kelvin. 298 in Kelvin. Right, and then for pressure, since we are using they give you in terms of bar, So we change it into Pascal because it relates directly to ATM. Okay, so what we'll do is this delta we change into Pascal. So when we get this value of Pascal for the system, this is the pressure for this condition now. So remember that we are now using the conversion using STP. So we arrange the equation that I showed you previously. So remember we want to find n. So when we rearrange the equation, so we get n equals to PVT standard divided by pressure standard, specific molar volume of standard, times T. Right. So we put all this information here. Okay, this is for TS. We know from previous table, TS is at 273 K because the reference temperature is at 0 degrees C or equivalent to 273 K. And for pressure, it is at 1 atm. 1 atm equals to 101325 Pascal. Specific molar volume for the SCM is 22.4 meter cube per K mole. And then we put the absolute temperature for this system. So we calculate, then we'll get the number of mole we obtain for this condition of nitrogen is 0.80726 K mole. In order to find the mass of nitrogen, so we take that number of K mole times by its molecular weight, then we obtain 22.61, around 22.619 kilogram. That's how you use the STP as unit conversion.